So this afternoon session, we'll be talking about two concepts. One is significant digits or significant figures, and then the other one is scientific notation out of the discussion from significant figures, okay? So what is a significant figure, class? Significant figure is a way in which a bigger number is expressed into a smaller quantity. If you look at the previous discussion about conversion, the biggest quantity that we had there was about, we reached until giga. And then the lowest probably we reached until, was it micro or nano? I think it's a nano value, no? So that conversion could be done in a way wherein we make use of a smaller quantity expressed in a scientific notation. But how to address the idea of changing a number to a scientific notation, first and foremost, we need to understand significant figures. Okay? In your module, the significant figures, I think, is somewhere in the last part now. So what are the rules in significant figures, class? Rule number 1, non-zero integers, that is from 1 to 9, are always counted as significant figures. Again, non-zero integers, that is numbers 1 to 9, are always counted as significant figures. In the example here, 3,456 has 4 significant figures. Okay, if you look at your module, class, allow me to share your module. I think it's not open. Let me open your module for a while, huh? Module Science 7. So in your module, class, if you look at here, you have rule number 1 as well. Rule number 1, all non-zero integers are significant. And what are these significant non-zero integers? That starts from 1 until 9. So in examples, we have 12.3, you have 3 significant figures. 35.46, they have 4 significant figures. Okay? Question regarding the first rule? Question regarding the first rule? None. So let's proceed with the second rule. The second rule there, I don't know if that is also in this presentation. I think it's none here. Let's start to answer first this one, class. How many significant figures are there in this number? Let's start with number 1. 7. How many significant figures are there in number 7? Elijah?
1.
1, correct. How about 40? Elijah?
2.
1
1.
still.
1.
How about 0.5, Elijah?
1.
1 still. Jeremiah, how about 0.000003? It's still 1. No? And then the next one, 7 times 10 to the power 5, it's still 1. And 7,000 is just the same as this one, only that this is 7 times 10 to the power 6 is also 1. That is showcasing the first rule, all non-zero digits are significant. So how do you know that these are significant? Important in other words. How will you know that they're significant? Of course, by following the rules. It's just like how significant is your life. You need to follow the rules, because if you won't follow your rules, if you won't follow the rules in life, you'll eventually die. You'll eventually get eradicated in this planet Earth. Like in the case of our new normal right now, the rule says wear a face mask and wear a face shield when you go to a mall. What is that rule for? For you to live, for you not to be communicated with the disease known as COVID-19. Okay? So let's proceed with rule number 2. What is rule number 2 then? Rule number 2, zeros between two other significant digits are significant. If you have a 0 in between the non-zeros, then that 0 is significant. Okay? When you are going to compare that rule in the examples that I gave, class, this 0 in the number 40 is not in between any non-zero integer, nor the 0.5, nor the zeros that is located in the next numbers after 7. They are not in between a non-zero integer. So therefore, this is insignificant, and the only significant value here is the 7, the 4, and the likes. Ma'am LB, nag-reply po si Kuya Carmelites. Nag-reply po. Okay, let's proceed. Not this one. So we have, again, what was the first rule there? Zeros in between two non-zeros are significant. Okay? There are three ways in which we're going to pinpoint the location of a zero. Because according to the third and the fourth rule, if you notice the module class, the third and the fourth rule says that if the third rule, the zeros that precede the first non-zero and then tells the location only of the decimal point, they are not significant. So for example, this 0 here tells us the location of the decimal point, and then it is succeeded by another 0. The two zeros here in the example number 3 are insignificant, and only 5 and 3 are significant. Okay? But according to the rule here, class, zeros may or may not be significant. Rule number 4 says that zeros at the end of a number may or may not be significant. Compare the examples, class. We have 2000 cm and 3000.0 liters. Zeros at the end of a number, which is significant number, may or may not be significant. In 2000 cm, you only have one significant figure. But in 3000.0 liters, you have 5 significant figures. Let's complete what rule number 4 says. Zeros at the end of a number are significant if they are to the right of a decimal point. Zeros at the end of a number. That number that is emphasized by this rule is a significant number. Again, zeros to the right of a significant number, which is also to the right of a decimal point, they are significant. So compare the examples 2000 and 3000.0. Question? Clarifications? Anyways, we'll have multiple examples later, so for you to understand what do I mean by this rule, or what does this rule further states, okay? So we have here 3 classes of zeros class. What's the first class? First class is leading zeros are zeros that precede all non-zero integers. All non-zero digits. These do not count as significant figures. Okay, this is what the rule says in number 3, or what the number 2 was that. So in 0.048, you have only 2 significant figures here. Leading zeros that determines the decimal point are insignificant. Again, the leading zeros that determines basically the decimal point and follows to the right of the decimal point are insignificant. However, if I am going to write a number here, class, let's say that I am going to write 1. Oh, wait. Where did I write the number? For why? Oh, where's the share screen? No one share screen, class. Okay, this one. What if we are going to write here a number, class? Can you see the share screen now? So again, leading zeros are not insignificant. They're counted as insignificant. In the problem 0.048, you only have 2 significant figures. But what about if I'm going to write here a 1? Then the number now is 10.048. How many significant digits are there? Angel.
Three.
You already have 5. Why 5? Because you go back to rule number 2. What does rule number 2 says? Zeros in between significant digits are significant. And take note, 1 here is a significant non-zero integer. 48 is a significant non-zero integer. So the ones in between becomes a significant digit already. Okay? But this is nothing to do with the first lead class, with the first class of a zero. Probably we'll repeat the same example later on. So what was the first class states? Leading zeros that precedes a non-zero, they are counted as insignificant. Precedes means gauna. Okay, they precede a non-zero. To follow is succeed. Let's proceed. Questions? Please raise if you have. By the time we are going to discuss the next um, the next class of zeros, then the example a while ago will be clarified then. And this is the one that I meant. Captive or sandwiched, the term is sandwich. Zeros are significant. And that was the rules, that was rule number 2. Diba? What was rule number 2 again? Zeros in between non-zero integers are significant. Therefore, we can also call them as captive or sandwiched zeros. So captive or sandwiched zeros are counted as significant figures. So in this case, the zero here after the decimal point that follows 6 is significant. So you have here 4 significant figures. Question? Let's proceed. How about the third case, class? This is the third case. Trailing zeros are zeros at the end of a number or zeros to the right of a number. They are significant only if the number contains a decimal point. So if we look back at the example in the module, 2000 versus 3000.0, this clearly emphasizes that trailing zeros or zeros to the right of a significant number are significant only if there is a decimal point. Kung walay decimal point, they are insignificant. So what's the difference between 3000 and 3000.0? It's nothing, no difference at all. It's just the presence of a decimal point. Okay? So in this example, we have 9.300. You have four significant figures. But in the number 150, you only have 2 significant figures, and that is 1 and 5. Okay? Question? Notice that 300 class, if you will say 300 point, it should contain 3 significant figures, right? But this is a wrong way of writing, huh? It is probably considered 3 significant figures, but you should not write it that way. Instead, you're going to write it as 300.0. Get it? Once there's a point indicated, there should always be a number that follows with it. In other words, a decimal point is located in between zeros or non-zero integers. If you write 0.83, and then perhaps someone in your classmate write only 0.83, I will mark this wrong. Instead, this is the correct one. Since 0.83 is the proper way of writing the 0.83. Get it? Why is that I'm trying to emphasize the correct way of writing significant figures here? For us, the correct way of writing the decimal point is always the case of the lesson. For us to understand the number of significant figures present in a said given, okay? So if we are going to write only 300, you only have 1 significant figure here. Okay? Clarifications? None. Okay, let's have a little quiz. Let's have a little quiz. I wish to ask a question. You wish to answer. Feel free to answer. Let's have this one. How many significant figures are there? Let's call our first victim for today. Casey, how many significant figures are there in the number 3,401? Any idea? I'll give you a clue. Zeros in between a significant number is significant. Choices are 1, 2, 3, 4, 5. Casey chatted the answer. Sir, I can see the right side. You can see the answer. Oh, sorry. I should change the settings. How about this time? Can you see the right side? Not anymore. What was that? Now, no, it's okay now. Okay. So probably Casey saw the answer already. Chloe, what's the answer here, Chloe? How many significant figures are there in 3,401?
4.
Very good. Of course. Now, good sir, no? Thank you, Chloe. The answer is a 4. How about 2,100? Charles, Godwin, how many significant digits are there in 2,100? The answer is 2. Correct. Very good, Charles. What about if we add a decimal point? 2,100.0. Rohan. Rohan? What's your answer, Rohan?
5.
Did Rohan give an answer? Okay, Rohan answered 5. Is it 5, Rohan? So the answer is 5, correct? It's 5. So why is it 5? You now include the zeros in between because this 0 after the decimal point is a significant digit. Okay? Confusing, right? I know, right? How about 5.00? 5.00, bench. 1, 2, or 3? Tulur mo na. 1, 2, or 3?
3.
3. Very good. 3. Ay, nga naman to. And then 0.0412, 3 as well is the answer. How about this last number? Rafael. What about the last number, Rafael?
Two.
The answer is 2. Your answer is 2. Probably that is wrong. How about Jeremiah? 8,050,000,000. Jeremiah?
6.
The answer is 6. Correct. It's 6. Okay, so according to Austin, she is confused of why this only turns out to have 2 significant figures while 2100.0 contains 5 significant figures. Okay? According to the rule there, trailing zeros may or may not be significant. These are trailing zeros. No? If you go back to the last, if you go back to the previous slide class, you have here. Where is that? Here. Trailing zeros are zeros at the right of the number, and then they are significant only if the number contains a decimal point. That is your only consideration. Only if there is a decimal number, a decimal point rather. So therefore, this is an insignificant zeros, while the next one, they are significant zeros because of the presence of a decimal point. Similar with 5.00. Sir, what about this one, sir? What about this number, sir? Why is it that this is not significant? This is not trailing zeros. These are not trailing zeros. These are trailing zeros, but they are insignificant. But if we are going to write a 0.0 here, then all of them become significant digits. Okay? So let us see some comments. Okay, thank you, Austin. Why is 8,008 billion 6? Yeah, only 6. Liam, was it Liam who chatted? Liam and Lian, only 6 because you only counted 8, 0, 0, 0, 0, and 5. These are the only significant digits here. So we have 1, 2, 3, 4, 5, 6. This is significant. This is significant. 8 and 5 are significant. Zeros in between significant figures are significant, making it 6. Whereas trailing zeros are insignificant unless there is a decimal point. Gets na, sir. Okay, thank you. So if you have clarifications, feel free to this one. How many significant figures are there? 1.2. Chloe. 1.2 is
2.
2, correct. 2100 is 2, that is repeated in the previous slide. 56.76 is 4. How about 4.00? It's a 3 because there's a decimal point and it's a trailing zero. But this is not a trailing zero from the next after 4.00, so it only contains 3. How about the last one? 7,083,000,000. Janessa. Janessa, what's your signal? What's your answer there?
4.
Very good. The answer is 4. So nasabtan, nakasabot questions, be? Clarifications. Or according to Austin. Very good, Austin. You get it right, Austin. Questions? We are still in the significant figures, Questions regarding the lesson on significant figures? Very good. So therefore, we move on to scientific notation class. Let's proceed with scientific notation. Okay. So we have here scientific notation. The number of significant figures are what we're going to use in order for us to determine how can we properly write a bigger number into a scientific notation. Scientific notation is a form of writing a number from a bigger perspective down to a lesser value component. Only writing a base of 10 and the decimal digits or the significant digits coming from the said problem. Okay? How we're going to make a number into its scientific notation. This is what you're going to remember, class. Move the decimal point after the first non-zero integer. Again, move the decimal point after the first non-zero integer, or move the decimal point after the first significant digit. If that is unclear, probably let's try these examples. Okay. So let's start with changing a scientific notation to a standard notation class. By the way, if this is a scientific notation, from this scientific notation, we can bring it back to a standard notation. In your module, you have there activity number 2. In activity number 2, you have there express the following in decimal notation. Decimal notation also means standard notation. So from the given class, you have here scientific notation. Make it into a decimal notation or standard notation, which we are going to understand in this presentation. So 2.35 times 10 to the power of 8. To change this into standard notation or decimal notation, notice the exponent of your base of 10. The multiplier times 10 ba? Notice the exponent of your base of your number which is in base of 10. If you look at it, it is positive, right? So according to the rule there, if the exponent of a scientific notation is positive, when you are going to change it back to its decimal notation, you move the decimal point to the right if the exponent is positive. Again, move the exponent to the right if the exponent is positive. So the end value there is a whole number. So we have here, um, sorry. So in the next example class, we have here, um, the exponent is now negative. By the way, that is written wrongly. It's not 10 to the 10 minus 7. That's 10 to the power of negative 7. Okay? So if we're going to answer this one class, perhaps the next slides, it was not answered. So we have here 2.35 is the original given. Okay? So from the exponent, which is positive 8, and then positive is the sign, so we move it to the right 8 times. 1, 2, 3, 4, 5, 6, 7, 8. And here you have now the location of your decimal point. What did we move here, class, is the decimal point. And the spaces left after moving the decimal point will be supplied by zeros. These are the insignificant digits that we just had eliminated upon creating the significant scientific notation. So in other words, your answer is 235 billion. Similarly, if you're going to change a number with a negative exponent, and the exponent then is the direction to where we're going to move the decimal point. If it is negative, class, follow the direction to the left, as in the Cartesian plane, di ba? So we have here 3.97. Since the exponent is negative, you move the exponent, the decimal point to the left 7 times. 1, 2, 3, 4, 5, 6, 7. And there you have the decimal point here. So we have here the answer. And since this is the decimal, it is a must that you write 0 preceding the decimal point. This will be discussed in the next slide. So we will proceed with the next slide, class. So we have here, from a positive exponent class. This is another example, not the example a while ago. 4.08 times 10 to the power of 3. Notice that the decimal point of 4.08 is in between 4 and 0, right? So what will we do now is move the decimal point in according to the exponent of your base of 10. Your exponent is positive 3, so the direction there goes to the right. Positive is to the right. So therefore, you have 1, 2, 3. Again, from the decimal point there, you move the decimal point 3 times to the right as the exponent says. So we have 1, 2, 3, and there you have the answer. 1, 2, tama, decimal point in tagan sa siya, no? And so the answer is 4080. You can have the answer 4080.0 or 4080 only. Question? None. Let's proceed with the next example. What about if it's a negative exponent class? Here. 4.08 times 10 to the power of negative 3. Since the exponent is negative, we now move the decimal point to the left. Negative exponent, move it to the left. So we have now 1, 2, 3. So you have the decimal point to travel 3 times. And after that, you finalize your answer by writing a 0 after the decimal point or before the decimal point. Okay? So there should be a 0 here, class. This part here. There should be a 0 here. If you don't write the 0 here, class, I will mark your answer wrong. Let's agree on this one. Clarifications. So that is when your exponent is negative or positive. So an easy way to remember, class, if the exponent is positive, move it to the right. If the exponent is negative, move it to the left. This is when we're going to change scientific notation to decimal notation. Put that in mind, class. Okay? So another example here, class. We have here plus 3, 3 spaces to the right. I think this is the example a while ago. And the negative 3, 3 spaces to the left. Exponent is negative to the left. Exponent is positive to the right. Question. Sir, do you have to put 0 after the decimal point if it is positive? No need so. No need to do so, Red. But if the exponent is negative, you have to really place a 0. Sir, when will you post this in YouTube? After I'm done uploading this in YouTube, I'll give you the link in Edmodo. Shamil. Okay, sir. Okay. So let's have these examples, class. Let's try changing the numbers into its standard notation. Looking closely to the exponents again. Huh? Look closely to the exponent. Positive to the right, negative to the left. Sir, Angel wants to ask a question. Yes, Angel?
Just the same question with red, sir.
Okay. Sir, do you need to put decimals at the end, sir? No need to if that is a whole number. If that is a decimal value, you need to write a 0. Let's have an example. Number 1. 9.678 times 10 to the power 4. So that would be 96,780. So from here, class, from this point here, we move the decimal point 4 times to the right. 1, 2, 3, 4. After writing the decimal point there. And then fill the empty spaces with a 0. So this is the answer of the question to the many. Sir, do we need to put a decimal point after a whole number? No need so. No need to place it. Okay, next question or next item we'll have here. 7.4521 times 10 to the power of negative 3. The exponent now is negative. Therefore, the motion of your decimal point moves from in between 7 and 4 to the left, 1, 2, 3. So you have the answer. We have 1, 2, 3. So the decimal point will be here then. And since this is a decimal, this is the time that you're going to write a 0. So the answer would be this one. 0.007 4, 5 to 1. Pardon class, I myself is Badlungon 1. There should be a 0 here. Okay, there should be a 0 here. So we have here the decimal point in between the 4, moving it to the left 3 times, 1, 2, 3. And there you have the decimal point located there. Okay, let's proceed. How about this one? 8.513904567 times 10 to the power of 7. The 7 value is positive, so let's move the decimal point to the right 7 times. 1, 2, 3, 4, 5, 6, 7. So the answer there would end up that the decimal point is in between 5 and 6. So your answer is this one. 85,139,045 and 67 cents or 6,700. Last number, 4.09748 times 10 to the power of negative 5. So the motion now goes to the left. 1, 2, 3, 4, 5, 6. Oh, sorry, 5 already. 1, 2, 3, 4, 5. So there you have the zeros. 1, 2, 3, 4. And then, of course, there's a 0 here. So to continue, you have the answer 0 fours after the 0, after the decimal point. 1, 2, 3, 4. We have 1, 2, 3, 4. Question? Mark and Boy, you understand, Mark?
Answer.
Mark. Mark is tired. You understand, Mark? Silence from Mark. Silence means a yes. Yes, sir. I understand, sir, according to Mark. Okay. So what about if we're going to change from standard to scientific? Bali na sa siya, class. A while ago, we we made sure that the exponents, positive and negative, goes along with the direction to where you're going to move the decimal point. However, we are going to, if we're going to change a standard to a decimal notation, we'll use the other side of it. If the exponent goes with a positive, then the motion of moving the decimal point from the standard goes to the left. Okay, bali-bali naman na siya, dagan-dagan naman na siya. So to understand it further, we have here an example. 3,258. Make this into a scientific notation. First, you're going to move the decimal point to the first whole number, which is in between 3 and 2. That would be after 3. As I said a while ago, move the decimal point after the first non-zero integer. It's time na. Oh my God, it's time na. Let's finish this one. So we have here 1, 2, 3. Again, balik. So the motion goes 1, 2, 3. So we have now the answer. As we move the decimal point 3 times to the left, the answer then would be 3.258 times 10 to the power of positive, negative. Positive 3. Okay? 2, 3. There you go. Positive 3. However, if you have the decimal, you're going to move it to the right, so the exponent now becomes negative. Okay? See as well, if the original number is greater than 1 or a whole number, the exponent is positive. If it is less than 1 or decimal, the exponent will be negative. That's also your clue there, additional clue. For example, here, the exponent is positive. So if you're going to change this to a standard notation, it's a whole number greater than 1. But if the exponent is negative, that is a decimal number less than 1. Get it? That's also your clue there, class. So let's have this one. Last one is here. Try changing these numbers from standard notation to scientific notation. So the number 1, we have 9.87234 times 10 to the power of positive, negative 6. 9.87234 times 10 to the power of positive 6. Because it's a whole number. Look at this one. It's a whole number greater than 1. So the exponent should be positive. Number 2, the answer there would be 3.45 times 10 to the power of negative 5, since it's a decimal. Then number 3, 8.376 times 10 to the power of negative 2, because you only move the decimal point twice and going to the right. Oh, sorry, this is negative 2, class. Typo. This is negative 2. And then number 4, we have here 5.673 times 10 to the power of positive 3. Yun. So this one is negative, ha? In your modules class, do not yet answer the operations on scientific notation. Do not yet answer the operations on scientific notation. If we still have time on Thursday, after checking the first 2 activities, then we might as well have the discussion on operations and scientific notation. Okay? And it's already time, so I think it's call it a day. Questions will be entertained by the time you check your work. Okay? If you have a question as well, kindly chat it in the GC or in the group, in my personal message in the messenger. Yes, Genova. Yes, Genova. You have a question? Oh, sorry. I thought you said like that. You babay pala. So that is all for today, class. See you Thursday for checking and for a potential continuation of the lesson. Bye-bye. Bye-bye.
Thank you, sir.
Just chat
Thank you.
your concern if you have a concern. Bye-bye. Bye-bye.
Thank you, sir.
Bye, sir. Thank
Welcome. You're
you.
welcome. Bye-bye. Bye-bye.